In today's episode, you'll learn about Boston Dynamics robot dogs, which have learned to speak using the GPT neural network. You'll see a pizza ad created by a neural network that intimidates internet users. We'll also tell you about the Dr. Octavius suit created in Japan, electric cars from Shanghai that can drive sideways and spin on the spot, Lockheed Martin's prototype small satellite service system, and SpaceX's launch of the world's first 5G telecommunications satellite. All this and more right now. Engineers and designers from Japan have developed a prototype of a modular system of additional wearable robotic arms, the arms. The system consists of a base unit, which is worn on the back like a backpack, and to which up to 6 robotic limbs can be attached. Engineers have been experimenting with wearable additional limbs for quite some time. As a rule, these are robotic arms that are attached to a person's torso or back and controlled either by themselves or by an operator. However, the existing prototypes are most often made in the form of a single arm or an extra pair. The new system, on the other hand, has a modular design based on a base unit. It is put on the person's back like a backpack and is held in tight contact with the body by several straps. The unit has 6 ports for mounting quick-release robotic limbs. The ports are paired in different planes so that the mounted arms do not interfere with each other's movement. Each port has an electrical connector in the center and an encoder to determine the angle at which the robotic arm is attached. The mass of the base unit is 4.1 kilograms, and the total mass of the system, together with the 4 arms attached to the terminals, reaches 14 kilograms. The length of the robotic arms was selected in such a way as to be approximately equal to the length of the user's arms when they are stretched forward in front of the user. The arms are removable and they can be replaced with other types of grippers if needed. The designers also tried to give the robotic limbs an anatomical resemblance to human hands. The system can be controlled via an application on a personal computer, as well as by means of the controller, made in the form of a halved copy of the basic module, and robotic arms attached to it. If the user or a third-party operator changes the position of the arms on the controller, it leads to similar movements of the robotic limbs. On the full-size prototype, the authors note the difficulty of controlling several arms simultaneously. For this, they had to involve several operators at once. In the future, the researchers plan to study the impression and feeling of people from long-term wearing and using modules with additional limbs. A strange video has been circulating the internet, either horrified or disgusted. The video is particularly virulent on Twitter and Reddit. An American created an ad for a non-existent pizza place called Pepperoni Hug Spot. Users in the comments unanimously think it's the worst ad they've ever seen. In fact, this ad was made entirely by neural networks. ChatGPT was responsible for the script, Mid-Journey for the images, Runway generated the moving faces, and the voiceover was done by Lep's neural network. Among the audience were those who think that such a breakthrough in content creation is a wake-up call for advertising agencies in the future. So far, the neural network team has produced frankly bad results, but there's no need to swear at them. Think back to the first results. Take a look. It's been less than 2 years, and now neural networks can generate hyper-realistic pictures. Similar situations can happen again in video. Interesting fact, anyone can dabble in Mid-Journey for free. BYD unveiled a new product in the high-end segment at this week's Shanghai International Motor Show, the Yunbang U8 electric SUV. The new BYD is the second representative of the ultra-luxury Yunbang sub-brand, joining the U9 BYD Yangfang 9 supercar. It is a large and brutal SUV with a total of 4 electric motors, a total of 1,100 horsepower and 5 screens in the interior. Thanks to independent motors, 1 per wheel, Yunbang U8 is able to perform tank turns, crab gate, and the power is enough to reach 100 kilometers per hour. But that's not all. The SUV body is fully sealed, and U8 is able to swim. The battery charge is enough for 1,000 kilometers of travel, and in the performance of the reserve power from 30 to 80% will take only 18 minutes. The Chinese SUV is based on the manufacturer's brand new E4 platform, also known as the architecture. It supports both all-electric and hybrid powertrains. The SUV will be available with a 5 to 7-seat cabin. The interiors are replete with leather and various displays, and its design is reminiscent of European sports cars. There are 3 screens on the center panel, a 23.6-inch digital dashboard, an identical multimedia screen for the front passenger, and a portrait-oriented media information system. Between them, There are a couple more 12.8-inch screens on the center console on the second row of seats. The manufacturer will prepare two versions of the SUV, Premium Edition for the city and Off-Road Master Edition for off-road enthusiasts. The U8 was originally expected to start at $120,000, but after the presentation it was announced that prices will start at $160,000. Thus, the U8 turned out to be the most expensive production Chinese SUV. What's interesting, the city and off-road versions do not differ in price. For the specified amount, the buyer, in addition to outstanding for the SUV, gets an 8-year support package on the roads, free individual charging station, 6-year general warranty, and a lifetime warranty on the electric motor. Lucid Group has announced that it has begun testing a pre-production version of its all-electric Gravity crossover on public roads in the United States. This is progress for the automaker, which has only one production model in its arsenal so far: the Air luxury sedan, which hit the market last year. Lucid announced its intention to launch the Gravity electric crossover back in 2020. When the Air sedan was announced, the company said even then that the crossover was in the design phase. Since then, the manufacturer has revised its plans, and the Gravity's production launch date has been moved to 2024. More precise information regarding the car's production, start, and sales launch was not disclosed in Lucid's announcement. That start of testing the Gravity on public roads came the day after the company's annual shareholder meeting, which included 3 new board members. Last month, by the way, Lucid announced an 18% reduction in its workforce as part of the company's ongoing restructuring. The layoffs will affect 1,300 employees in various parts of the company, including the executive team. Boston Dynamics engineers have added GPT neural network support to their famous Spot robot dogs. The robots can now answer questions and talk about their plans. The upgraded version of the robot has a new GPT-enabled neurochip, as well as speakers that make Spot's voice come through. The voiceover is similar to Google's voice in Google Translator, for example. Thanks to the integration of GPT capabilities, a person can ask about the battery charge and the robot will answer how low it is. Also, a person can ask questions about any topic, and the neural network inside the robot will find useful information. The robot can voice its tasks, for example, to answer the question about what it is doing now and what it will do later. Finally, the robot learned to gesture to answer unambiguous questions. If it thinks a question can be answered, yes, it simply nods its head. It looks pretty cute and appealing. SpaceX launched the world's first 5G telecommunications satellite. The relatively small 10 kilograms big groundbreaker repeater will be the first in a constellation of 250 satellites in low Earth orbit. The new constellation from the Spanish company Satellite will connect the spacecraft with ground-based cell phone towers and fill gaps in coverage. Satellite is going to offer its services to public and private organizations representing a wide range of industries. But above all, transportation: road, rail, water, air. By connecting an Internet of Things device to the satellite network, the company hopes to expand the capabilities of mobile foreign devices. Users will be able to easily switch from terrestrial to extraterrestrial 5G networks without purchasing any additional hardware, like modems or antennas. There will be no need to change SIM cards or mobile service providers. A satiated barker has already taken care of roaming. The U.S. military-industrial company Lockheed Martin has tested the in-space upgrade satellite system. It is expensive to deliver cargo into orbit, and in case of even minor malfunctions, it is often more profitable to send a new satellite than to return to Earth and repair the old one. However, little by little, private business is beginning to offer spacecraft repair solutions directly in orbit. Service modules can dock with obsolete or broken satellites. They repair them, return them to normal operation, and fly them to the next broken satellite. For large geosynchronous satellites that are part of global telecommunications networks, this method works well. But for small satellites no bigger than a loaf of bread, of which there are more and more in orbit, the technology for repair and maintenance does not yet exist. One solution Lockheed Martin offers is the LM-Linus system, made up of LM-502 CubeSats designed to perform autonomous docking and positioning operations to maneuver among constellations of multiple satellites. That's all the system's capabilities so far, but someday it will be able to serve the vehicles it's currently learning to fly between. The company is convinced that in the test, one of the satellites acted as a passive target and the other as a repair vehicle, using only navigation algorithms and artificial intelligence. The maintenance satellite successfully approached and docked with the target. In addition, the satellites tested Horizon 2.0 and SmartSat control software, established connectivity for telemetry, tracking and control, and demonstrated low-toxic propulsion systems, machine vision, and 3D printed components.